But a really important part we play is the interconnection between these different major goals. And that's where a lot of the focus needs to be over the next 5 years, as many of these goals come to completion. So let me take you through a slide or two on each goal. We'll start with water quality, since that's the one so familiar to many of us. So the water quality goal is to reduce pollutants to achieve the water quality necessary to support aquatic living resources. That's the main focus, as well as protect human health. And it really is dependent on the designated uses in the bay. These designated uses were set up to support aquatic life. So we have designated uses for migratory fish in the rivers and fresh water. We have shallow water areas, designated use for bay grasses, open water for finfish and shellfish, all the way down to deep channel, which is used seasonally. So the two big outcomes here are, one, to reduce nutrients and sediment coming into the bay, and then secondly, to attain all these water quality standards. Well, most of the focus has been on really trying to reduce the nutrients and sediment, and that's part of the TMDL framework. And each state had to write a watershed implementation plan prescribing how practices they'll put in to reduce nutrients and sediment to the bay. And that's where most of the focus has been. But I think as we get closer to 2025, that's when all the practices have to be in place. People are going to be looking more at, well, did we improve water quality in the bay by measurements of standards? So I see that as one of our first big science challenges of really understanding estuary response to nutrient and sediment reduction. This science has been going on for several decades, but there's still a lot of unanswered questions. Particularly, are we seeing the watershed response we expect? This shows in some areas for nitrogen, for instance, through 2018, about half the sites of nitrogen are improving, but a similar amount are still worsening. Does that then step down into reduced loads to the bay? This shows loads through 2018. As you guys well know, the loads are influenced by both land use and then the amount of rainfall we have in a particular year. In both 2018 and 2019, we had lots of rainfall, therefore lots of loading to the bay, which results in these dissolved oxygen conditions that a graph from last summer, where you still see very low dissolved oxygen in large portions of the bay. And this is from Maryland DNR. So really there's a lot of science questions. When we're sitting at 2025 and the states go, we've done our job, we've put in our practices, people are going to say, well, what about attainment of standards? And STAC has undertaken a large synthesis of data gaps and what we know about this connection. And I think the science questions coming out of that STAC review are going to be really valuable to take us into more research till 2025. Another part of water quality is toxic contaminants. This is an issue because 80% of the bay is either partially or fully impaired due to toxic contaminants, PCBs being one of the major contaminants. So the goal is aspirational, trying to make the bay and its rivers free from these effects. There's two outcomes, one on policy and prevention. That's focused on PCBs because of their prevalence, and that's also the main cause for fish consumption advisories throughout the bay is PCBs. The research focus moves beyond that group of contaminants and really looks at the menu of legacy contaminants all the way through more emerging contaminants such as PFAS. And the science challenge here is a lot of these contaminants are within the same settings as where we're trying to reduce nutrients and sediment, where it's either ag lands all the way through to suburban or wastewater treatment plants. So the challenge is trying to come up with, can we identify the co-benefits of which practices we're putting in for nutrients and sediment can also mitigate contaminants and their effects. So a lot of research opportunities there. We'll move on to fisheries, because this is one of the main things we're trying to sustain. A lot of the fishery goal focus is within the estuary, but it does reach up into the watershed. there's a large goal focused on oyster restoration, 10 reefs. There's a session right after this, so I'm not going to go into the science goals for oyster restoration. Let me focus on crabs a little bit. So crab abundance is really important, and this graph shows essentially the abundance, annual abundance against the minimum threshold of 70 million female crabs versus the desired threshold to be maintained of a little under 220 million crabs. So you see a lot of variability in this. So there's a lot of science needs to explain the factors affecting this variability, which range from crab harvest, which is one of the management practices we try to implement, to the environmental factors that influences them, temperature, discharge, etc., predator-prey relationships, and as we improve dissolved oxygen, are we going to see more crab populations be sustained? Those crabs depend on vital habitats, and this is where we start getting up into the watershed. While our first three goals are focused on habitats that are looking at a network of land and water in the estuary, this goal takes us more up into the watershed also. So in the estuary, we're focused on goals to try to improve habitat conditions for black ducks by bringing back wetlands and SAV. But as we go up into the watershed, this is where fish passage becomes very important, because we want to look at the stream and river conditions that will support fish passage into the watershed, as well as the habitats in the watershed that those fish depend on, healthy streams, etc. So that's where there's outcomes focused on stream health. As you get up into the headwaters, it's even conditions for brook trout. And some of what they depend on is forest buffers and forest canopy. So this is a wide-ranging goal with many science needs. Some of the big challenges here are really affecting connecting the fish and wildlife to those habitats and the aquatic conditions that are under the water quality and contaminants goal. So this is where there's really a lot of science opportunity, trying to connect what are we learning in the estuary about nutrient reduction and increases in habitat conditions for fisheries, but then also along the coastal areas as we bring back habitat for waterfowl. We're not just focused on black duck, we want to be focused on multiple species that use these environments. And then up in the watershed, it's trying to make connections between freshwater fisheries, stream conditions, and aquatic conditions, as well as getting all the way up to the headwaters, trying to look at streams and making sure there are sustainable conditions for temperatures needed by brook trout. So making this connection from estuary to headwaters is really important for science needs going forward. All this is really also being affected in the face of climate change as the estuary and rivers warm over time. So to talk about climate change, we have a goal for climate resiliency. And this is really cross-cutting. It's really to increase the resilience of the watershed and bay and everything that depends on it. So the factors that they're looking at is trying to come up with adaptations due to sea level rise, nuisance tides shown here in Annapolis, all the way through to monitoring to look at changes in stream flow or temperature due to climate change. So the science needs here are robust because they cross the other goals I've just described, and we have a work group focused on trying to move this forward, and STAC played a big role in bringing this issue forward for the Bay Agreement. I think one of the big science challenges is to look at the combined impact of climate and land change. And as we all well know, both development and climate affect our landscapes. And so there's a lot of science being done on trying to forecast those changes in the future. Here's an example showing where developments most likely occur out to 2050, work done by the USGS. The darker blue is where it's most likely to occur. And that's used to help focus where protection might be most beneficial. But we're also seeing that not every watershed responds the same due to climate or land change impacts. So better trying to understand the vulnerability and resilience of different watershed characteristics is an important part of the science that's needed moving forward. I talked about protection. So there's two goals related to healthy watersheds and land conservation. One is the healthy watersheds goal, and that's just shown this map here where all the areas in blue are where the state said these are healthy waters we want to protect. There's another goal expanding this out to say besides those areas, we also want to try to protect important working farms and forests. And so there's a goal to protect 2 million acres in the watershed. That's starting to show in green here where some of that conservation is occurring. And there's science to say we need forecasting to say where are these areas most vulnerable so we can help guide protection in the future. The last part of these goals is really to get more people more involved within the Chesapeake Bay restoration. So there's a stewardship goal to increase the number and diversity of people involved, as well as an access goal to have them be able to enjoy the bay and its rivers more by having 300 new sites in by 2025. And then finally, there's a goal to bring the next generation along, looking at environmental literacy and really going into schools and having strong programs so they learn about the Chesapeake and therefore build a connection for its restoration. Those last goals for stewardship and in literacy, the challenge is really taking advantage of social science to connect people to the restoration. There was a principle in the Bay Agreement to explore the use of social science, and I think we're all happy to see more of a focus on that over the past year or two within the Bay program, and that'll be a growing science application. So finally, just to finish up, all these Bay program goals and outcomes, many of them are needed by 2025, so the science really helps direct the best use of resources through a Chesapeake Bay decision framework that's shown here, where we have places to plug our science in. And I think this really helps inform decision making. It's really on us also, besides the research, to translate those findings into usefulness for stakeholder decisions, as we heard yesterday in the plenary speakers, and identify new threats to the ecosystem. So Emily Trenicosta is going to talk a little bit more about the strategic science and research framework, where you're trying to match up the science needs of the different goal teams who are responsible for carrying out the outcomes I described with the science providers, many of you who are on the symposium today. And then we work through STAR to try to coordinate this connection by summarizing the needs, seeing which providers can meet some of those needs, and what are the opportunities to conduct and apply more research. And STAC is involved with this effort and also gives us future direction. So that's what I had today. Thank you for the opportunity to present. And I think we're going to try a Mentimeter question to see where a lot of the science is that you all conduct in relation to those 10 goals.
Great. Okay, and I see Emily's coming on. Thank you, Scott. That was a lovely presentation. Now, Emily, are you going to post something for the audience to respond to?
Yeah, so while we're getting some questions in for Scott, I'm just going to post a Mentimeter question. So Raleigh, let me know when you see
I see it.
My screen there. Great. So this is a really neat program, Mentimeter, that we can use to get some real-time feedback and ask you guys questions. So what I would ask is that everyone go to www.menti.com. It's at the top of the slide there. And then you can either do it on your phone or on your browser. And then you just put in the code that it says at the top of the screen, which is 158463. And you can start voting on this question. And why don't we just leave the voting open while we take some questions for Scott?
Okay, that's great. And so, but I think before we take questions, I should introduce Emily, who's our next speaker. Emily Trenicosta is an environmental scientist with the EPA's Chesapeake Bay Program Office and coordinator of the Chesapeake Bay Program's Partnership Scientific Technical Assessment and Reporting Team. Her work focuses on integrating scientific and technical information across the Chesapeake Bay Program Partnership to provide technical assistance to state and local partners and on coordinating efforts to assess and address the partnership's science needs. Emily has previously worked as a biologist and presidential management fellow conducting environmental assessments in EPA's Office of Water and as the National Outreach Coordinator for NOAA's Fisheries Office of Agriculture. Okay, so we've got Emily properly introduced, so everybody knows who she is, and she'll start her talk in about 8 minutes or so, but let's go ahead and folks can go to the website oh, look, we've got tons of responses coming in. Look at that. And also we have time for questions. So please go ahead if you have a question for Scott, post it. There is a comment from Joseph Zhang, Scott, that came up earlier in your talk at the very beginning. He was referring to one of your early slides that seemed to, I think it was the diagram of, current degraded conditions versus future. Right. Scott's slide seems to suggest that in the future, the Chesapeake Bay will have less precipitation.
No, that was supposed to represent less atmospheric deposition of nitrogen.
Ah, I see.
Through the Clean Air Act controls. So sorry I didn't go into that in detail.
Any other questions from the audience? I think everybody's so excited about doing the Menti.com thing.
Yeah, so this is some interesting results because, I mean, one, I find a little heartening that we've got some robust efforts across the categories that Emily put up. I was afraid with this audience we might see water quality just dwarf everything else.
Right.
But I think as we've been talking about, we have science needs across these activities and trying to make the connection between them. So it's good to see we've got a pretty good diverse group here.
Yes, and a lot of responses. And for the audience, we're up to 154 participants.
Okay.
Okay, we have a question from Don Bosch. As we approach 2025, it will be critical to resolve whether nutrient losses from agriculture have declined as much as the watershed model predicts, but empirical data do not show. How will we do that?
Yeah, that's an important question, Don. I know that the phase 6 model, we tried to put in more information, especially about how some of those nutrients are stored in compartments, whether it's nitrogen in groundwater, they put in a groundwater term in the Bay model, or phosphorus stored in soils. I think there's some good thinking by STAC trying to improve that, but I agree that's going to be a critical piece to improve the science behind, especially since the majority of the states are depending on the agricultural sector for their BMP reductions. But there might be others who have would want to chime in the chat for an answer to that really focus on that issue.
Any other questions?
Well, I guess to tee up Emily a little bit, what she's going to go through is we spent a lot of time over the past 2 years trying to look at the science needs for these different goals, goal teams that you see on this bar graph. And so those are now in a strategic science and research framework, and Emily's going to go through and talk about some of those needs in more detail. And then more importantly, really talk about how you can get more plugged into addressing some of those needs. That's the part I think we really need to build capacity of our science providers to meet some of these needs. And we all have some very worthwhile research, but I think trying to get more involved in addressing some of these needs, we can help with the research that you're doing, whether it's letters of support or places you can really apply those findings to management decisions. So that's what Emily will go into for the next talk. And we're seeing some fruits of those labors. Yesterday, Emily and I ran a session where, we showed EPA is moving beyond the Bay program and really reaching into Region 3 and their Office of Research and Development to bring in more capacity. USGS has done a similar approach. So it's starting to work, but it's going to take a while to build that capacity when you see the large amount of needs that Emily's going to lay out.
Yeah. Okay, we have another question from the audience from Sean Reed. He asks, when validating the benefits of BMPs, et cetera, has there been much work to try to separate the impacts of interannual weather/climate variability?
Great question, and always a very difficult undertaking. I know for a lot of the BMP validation, there's been expert panels set up, and those expert panels bring people together for a particular group of practices and try to come up with an average value of efficiency for that BMP. And they do try to take into consideration what would it do by trying to take out the effects of annual or even more frequent rainfall, et cetera. I think when we look at trends, we also try to take out that effect of annual variability by doing flow adjusted or flow corrected trends, both in the watershed and the estuary.
Any other questions for Scott? We still have a minute or two. And so I just want to reiterate Scott's previous point, especially for the younger folks in the audience, that one of our goals here with these presentations was to help provide guidance for people for the research community to actually figure out what the priorities are for research. So, you should be thinking about, as we go through these talks, about, how these needs and these goals that have been set forward by the Bay program might mesh with your own research interests, and thinking about, well, gosh, maybe I could write a proposal to the National Science Foundation or to NOAA or some other agency to try to address some of these questions. I have now a question from Bill Ball. As a follow-up to both of the preceding questions, it is well understood that BMP efficiencies vary tremendously over time and space and are dependent on many different factors. This seems like an area where research is still in infancy.
Totally agree, Bill, and not just for nutrients and sediment, but for contaminants and habitat recovery also. As I mentioned, the expert panels try to come up with an average value that end up in CAST, one of the tools used, but I think you are right on that we really need to see how these BMP efficiencies vary in different landscapes and watershed characteristics.
We have a few seconds left. Maybe if anybody has one more quick question. Andrew Warner asks, what are the strengths of 1, GCM downscaling, and 2, tools methods for prioritizing management actions across the basin?
The downscaling, I know there's a lot of pros and cons of, we definitely want to try to downscale, but I know as you try to downscale these models that are at a very coarse scale, trying to get the resolution in something like the Chesapeake Bay is tough. It's problematic. So that's a challenge, trying to come up with more robust climate projections in smaller areas.
And the second part was tools, methods for prioritizing management actions across the basin.
Yeah, so there, besides for water quality, the Chesapeake Bay Program watershed model and a coupled model of the estuary is one of the major tools. But we are trying to link those to other goals. So there was a mapping exercise showing areas where you could get restoration benefit from several goals, same with conservation, that exists. And then a lot of that is shown in what's called the data dashboard. It's trying to pull together tools for other outcomes to use to make better decisions for multiple goals, not just water quality. And that's in beta testing right now. It should be released fairly soon. Emily Trinacosta has been heading that up.